Hello guys and welcome. Today I'm with you with another video. Let's begin. So today we're going to do question 26 to 30 from Math League Contest. Okay, grades 5 to 6. Okay, before I start, I want to show you something and ask you something. See, this is the channel from which you see the video, but I only have, I don't know when you will be watching this, but at this time I have only 5 subscribers. Please consider subscribing it. This number is, well, not very good. So please subscribe to the channel. And let's go. Let's do question 26. Okay, please read the question. Okay, pause the video. Okay, so now we're going to do it together. We're going to throw, well, we're going to toss dice, right? 6 times. And we want each time to get one of the numbers, like, so we're going to get 1, 2, 3, 4, 5, and 6. And we're going to get each one once, right? So if I get 2 5s, well, no, that's not what we're looking for. If I get 3 5s, that's not what we're looking for. So I'm gonna throw the dice, right? What is the chance that I get one of these? 100%, right? So the first time I'm gonna write 6 from 6. The first time that I throw the dice, any of them is okay, right? So let's assume that I throw the dice and I get a 4. Okay. And then next time I throw the dice again. If I get 4, I lose. But I still have 1, 2, 3, 5, and 6. If I bring those, I'm still in the game. So I'll have 5 options from the 6 options because 4, or the first number that we brought here, is not there. And then let's assume randomly I bring a 1. Okay, and now what are the chances? You get the idea. I have 4 over 6 multiplied by 3 over 6 multiplied by 2 over 6. And the last one, there's only one number left, 1 over 6. You do the multiplication yourself. I'm not going to do it, but that's basically the idea. Okay, let's go. Question 27. That could be one of the most challenging questions of this series. Please, my picture is on the question, I think. Let's just put myself here. Okay, please read the question. That's a little challenging question. Okay. So, well, before answering this question, right, let's answer a different question. And that question is, how many games are required? See, if we have 17 teams, right, and each team wants to play 9 games, how many games do we need? Is that the answer? Is it? So it's going to be 153, right? Yeah. So do we need 153 games for all the 17 teams to play 9 games? Is that your answer? Well, let's just show you something. Let's come up with an easier number. Imagine that we have 5 or 4 teams, and each one wants to play 2 games. So team 1, team 2, team 3, team 4. each team wants to play 2 games. Let's see, for example, let's just put these names, Team A, Team B, Team C, and Team D. Okay, randomly. See, even the book says they could play against a team 2 times. So let's see, for example, this is also one possible answer. A plays 1 times with D, plays again with D, 2 games, and 2 games. So how many games did we play? Huh? Or let me put it like this. A plays with B, B plays with D, D plays with C. Okay. And then C plays with B. Okay, C is done. Oh my God. So, and A plays with D as well. You see, each of the lines represent a game. See, B with C plays once. Look at here. B plays, oh, but there's something wrong here. I don't need this. Okay, that's now each team to each point comes 2 lines, and lines represents games. So 2 games here, 2 games here, 2 games here, 2 games here. So how many lines do we have? 1, 2, 3, 4. So with 4 games, 4 teams can play 2 games each. Okay, but if we use that formula, look, if we use 4 times 2, so we need 8 games if we do it like this. No, you see, we would only need half of this. So basically, if we have 4 teams and each one wants to play 2 games, 4 times 2 divided by 2. Why divided by 2? Because look, one game, one of these lines, it's just 1 game for A, it's just 1 game for D. Okay, that's why we need to divide it by 2. Now, let's just use that formula. So we want 17 teams to play 9 games. So 17 teams we have, 9 games, but we need to divide this by 2 because each game goes for 2 teams. Okay, so the number of games will be this, 17 times 9 divided by 2. And it would be 153 divided by 2. It's going to be 76.5 games. Is it even possible for 17 teams to play 9 games? No. So what are the possibilities? Well, 0. Okay. So let's go question 28. Well, question 28 is all about understanding it. So please, I'm going to put it here. Pause the video, read it. Pause the video and read it. Okay. So, did you understand what it says? Well, basically, the question is very easy, only if you can figure out what it wants. Okay, so I'm just going to put this part. This is basically what it says, what we need to do. In a group of 5 people, is it possible that no matter what 3 people you pick, there always exist 2 who love each other, and there always exist 2 who hate each other? What does that mean? See, we have 5 people. People are represented by these points, these vertices. Okay. And let's see, I don't remember the question. Let's see, this is red is love and blue is hate. Okay, so what happens if I have this? Look, if I have these pictures, well, if I have a triangle in my picture, a triangle that all of them are red. So for these 3 people, everybody would love each other. And that's not what the question is looking for, right? But if I have a triangle and one of them is different color. So blue. Now let's see. There always exist two people who love each other. These two people love each other. And there are always two people who hate each other. These two people hate each other. Okay. So what does the question want? The question wants you, okay, to go from each of the points to all of the lines. So we're going to go like this. From each one, we need to go to all of those. But when you do this, if you get a triangle that is all red, or you get a triangle that is all blue, you lose, okay? But if you can get it, you draw all the lines, and there is no triangle with the same color, then the answer would be yes. Is it possible? Yes. So I'm going to try to do that. So definitely this one has to be blue. This one, I will put it blue. This one, I will make it red. And this one red again. This one blue. Okay. So that's pretty good. I have no triangle. You see, for example, this triangle here. Two of them are blue. One of them is red. So I'm still good. How about these two lines? That's you see, if I put this like this, I lost now. Why? This triangle over here, this one is all red. So this one has to be blue. Okay. So, and then can I go like this? Yes. Is there any more line to draw from each one? Yes. Yes, there's one more. If I go from here to here, ta-da. So each point, each vertex should get 4 lines to it. 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. Yeah. So is it possible? Yes. Okay. Remember, when I said no triangle, look at this one. This is not what I mean. Just look at this triangle. It's all blue. But that's not what I mean, right? Because this triangle is not between the points. When we see triangles, I mean the triangle between 3 people, like this one. You see, let me highlight it better. So for example, because that shows relationship between people. Okay, you see this triangle, okay, not all of them are not of the same color. Pretty good. But this one, if you say that's a triangle, well, this one is between who? Between which vertices? No one. Okay, so that's not what I mean. The answer to this is yes, but there is also one more thing that you need to do. You need to do this yourself. Write it in the comment section if it's a yes or if it's a no. Okay, later I could confirm what my answer is, if it's correct or not. Okay, so that's question 28 as well. 29, please read it. When I say did you read it, I mean like, did you read it? Did you spend time doing it? Okay, if you first time you see the question, maybe 15 minutes, 10 minutes. Okay, if you can get the answer to the question. Okay, so basically we will have again a dice question. We will throw 3 dice. And we want the dice to give us a total number of 7. So for example, remember, each dice has 6 options. So the total number of possibilities is 6 times 6 times 6. Okay, 6 to the power of 3. But to get 7, okay, what numbers could create 7? You see, if I bring 5 and then 1 and then 1, that's 7, right? So let's see, let's get everything here. That's gonna be 5, 1, 1. All right, 1, 5, 1, 1, 1, 1. Okay. How about 2? 2, 1, and 4. This is another one. Okay. 2, 2, 3 is another one, right? 3, 3, 1 is another one. Is there any more? Okay. No, not with 6. Oh, 4, 3. Okay. There's no 0. I think that's all. Okay. So, and then, well, when we say 5, 1, 1, well, it could also be 1, 5, 1. It could also be 1, 5, 5. Like, so that's 3. Okay, when I write it like this, that's 3 options for this one. So this one will be a 3 options. Okay, this one again, this one will be 3. This one will be 3. This one, you could write it yourself. If you're not sure, will be 6. Okay. So let's add them all up. 9 is going to be 15 over this. So let me see this. Okay. As well. Okay. Sorry, guys. So that's going to be 15 over 6 to the power of 3. So we're good to go. And we're done. So the last question is question 30. Okay. So that's going to be the question. Let's just keep it. Let's just do it blue for once. Okay. So please read the question. Okay. So this one is a established question, and I'm not going to answer it. Instead, I'm going to show you a website. Okay. Basically, the question is circle division by lines and the possibilities. This one is the first part of the question, so it's a yes. And here is the formula, so you can read it. So no problem with this. And I think that brings the lesson into an end. Okay, please subscribe to the channel. And that's enough for today. We'll still have 2 more videos. So see you soon. Take care and bye-bye.